value containers and for other circumstances where two values are used as a single unit. So let's take a look at that, and we're going to make a working copy of the file tuple.cpp, and it's called that for a reason, and you'll see that in a bit. And we paste that into our working project and open it up here. I'm just going to scroll through it real quick so that you can see the whole file. You notice on line 4, I'm including the tuple header. And if for some reason you're not using C++11, your system probably won't work with that header included because you won't have that header. And so you'll need to delete that line. Commenting it out probably doesn't work. The C preprocessor sometimes doesn't understand C++ comments. So up here at the top of our main, you notice that we're declaring a pair. And a pair is a template class. And so you have to pass it a couple of types. And so those type parameters are in the little angle brackets. The first one is int and the second one is string. And you can put whatever types you like there. Your pair can be a pair of any two types, including classes. As in this case, you see string is actually a class. And then I initialize the pair with an int and a string. And you see that the name of the pair is P. And then in parentheses, I've got the two elements for the constructor, the int and the string. To access the elements of the pair, it's really very easy. The pair type exposes the data members first and second, and there they are. We see them printed out here. We'll go ahead and compile and run this, and you see them printed out 42 and 42. And then we have a second, actually the same pair, just reinitialized. And so the make pair template function, and again, you can pass it any two types, and here I'm passing it int and string. So its arguments are an int and a string, and it returns a pair type. And here I'm using the assignment operator, that's the equal sign here, to assign it to the pair P. And of course, I could use this as a copy constructor and have exactly the same result. So really, that's all there is to pairs. They're very simple, and they're very useful, and you'll see them used a lot in some of the other container types. Now we're going to get to tuples, and I'm going to go ahead and I'm going to uncomment all of this stuff here, and you'll see in a moment why I have this commented. I'm just going to use Command/ on this Mac. I believe it's Control/ on other operating systems, and that will uncomment all of that stuff. And I'm going to save it and compile and run it, and you'll see that it works in spite of all these red bug symbols. And those red bug symbols simply mean that Eclipse doesn't know what to do with this. I have a version of Eclipse that's current as of the date that I'm recording this, and it still doesn't understand a lot of C++11 syntax. And tuples rely on a brand new C++11 feature, which is variadic templates. And I can understand that Eclipse doesn't quite know what to do with that. Hopefully another version soon will. And so tuples are basically an extension of the idea of a pair. It's new in C++11. And as I said, it's based on the idea of variadic templates, which is a new feature in C++11. And you can look at it a little bit as a generalization of a struct, or if an array were able to have more than one type. So here I'm using it with 3 strings. It can be a string, an int, and something else, and it would work just fine. Any 3 types or any arbitrary number of types. It can be 4, it can be 5. Tuples are flexible in that way. But here, just for demonstration purposes, I'm using 3 strings. And initializing the constructor with 3 arguments, and they're 1, 2, and 3. Strings of the string of the names 1, 2, and 3. And then I'm displaying it with this get function, and yeah, that's a function. It's a template function, and here, where you would normally see a type in a template function, you're actually getting a number, and that's an index into the tuple. So get 0 of T1, get 1 of T1, get 2 of T1, and it simply prints out this 1, 2, and 3, those strings. So it looks a little odd. Once you get used to it, it's actually pretty straightforward. And then another way to do this, here I've declared 3 strings, and I'm using the tie function, which is another template function. And what tie does is it returns a tuple of references. And so in this case, it's returning a tuple of references to those 3 strings, A, B, and C. And I'm assigning the tuple T1 to the tuple that gets returned by tie. And it's a reference to a tuple. And so in this case, it's actually just copying those values into these strings at A, B, and C. And we can print out A, B, and C. And you see, here's our result there, 1, 2, and 3. And then as an extension of that idea, for my references in tie, I'm actually putting in get 0, get 1, and get 2 in reverse order of this tuple string of T2. And I'm assigning T1 to that. And what that ends up doing is basically reversing T1 because I've got them in reverse order. And then I look at T2, get 0, get 1, and get 2 of T2, and we have 3, 2, 1. So you can actually initialize a tuple with the tie of another tuple in a different order. So I know some of the syntax looks a little bit weird and it looks a little bit complicated if you haven't seen something like this before, but it's actually really simple once you get it. So pairs are very common in the STL, and we'll be using them a lot. Tuples are new in C++11, and they're not yet widely used, but I can see how they could come in very handy in some circumstances. Now let's delete our working file.